In these next three videos, we're going to look at the strengths of acids and bases. And so we're going to start off this video looking at the ionization of acids. Now, if we had some acid, and we're going to make up an acid, we're going to give it the formula HA, and we know it's an acid because it starts with a hydrogen, which indicates that hydrogen is ionizable. So the ionization equation for this acid, then, we're going to write it two different ways. Here it is in the Bronsted-Lowry model, where we have an acid here, and we put it in water. So this acid is going to donate a proton or a hydrogen to the water, which forms the hydronium ion. So we have an acid, makes the water the base. The hydronium becomes the conjugate acid of the water, and then this ion, this anion, A-, is then the conjugate base of the acid. Now we could write this another way that's much shorter, and we'll write it probably this way a little more often as we go forward out of this chapter. If we have HA, it's aqueous, it's just going to ionize into hydrogen ions and A ions or anions. This is the Arrhenius model. Remember that Arrhenius just said that acids produce hydrogen ions when you put them in water. But now here's the thing about this. The opposite reaction to that is also a possible reaction. So all I did here is I cut and pasted the products of one side on the reactant side, and then the reactants on the product side, and kept the arrow exactly the same way. And so I've got that in both Bronsted-Lowry and also Arrhenius form. So this reaction is also possible if the hydronium ion reacts with this anion A to go back and produce the acid again and some water, or just recombine the two ions, as it shows here, to form the original acid. So a lot of reactions, not all of them, but a lot of reactions are reversible. Okay, so if we rewrite this as a single equation, now I started with the acid and the water. Here's the hydronium ion, and then this negative A anion. And notice I've put a double arrow here indicating that this reaction is reversible. It can go in either direction, and we're going to talk a little more here on another video about how to know which direction it's going to go. So Bronsted-Lowry form here on the top, here it is in the Arrhenius form on the bottom. So we have two ways of writing the same reaction, and now we have a new way. This indicates that this reaction is reversible, and the fact that these reactions are reversible is going to open up a whole new set of opportunities and things that we're going to be able to do with that. Now, the one thing about this, though, is just because they're reversible does not mean that the forward reaction, and let me back up here, the forward reaction will be the one from left to right. Whenever we look at it, whatever's on the left going toward the right is called the forward reaction, and then from right to left is the reverse reaction. So just because we have those two reactions going on and it's reversible does not mean that those reactions occur in the same amounts. Okay, so in the next video we're going to look at what happens when we have different amounts of forward and reverse reaction.